Hello guys, we want today to solve paper 4 2019 May June, and let's start the first question, which states that a bus is traveling between points A and D. There are bus stops at A, B, C, and D, but the bus does not stop at B and C. Figure 1.1 is a speed time graph for the bus. As you see, we have a gradient, or we have graph, speed time graph, speed in kilometer per hour and time in minutes. A. Describe the motion of the bus between each of the bus stops. Select the appropriate description from the list below. We have many sentences. We'll choose any one of them. Constant acceleration, decreasing acceleration, increasing acceleration, moving backwards at constant speed, moving forwards at constant speed, and stationary. The first one, between A and B. If you look between A and B, as I said, you have a graph, speed time graph. So the gradient of this graph will give us what? Acceleration. But in this case, the curve will be less steeper. This means that we have decreasing acceleration. The acceleration is decreased. So decreasing acceleration. So we can write here. Decreasing acceleration. Yes. Between B and C. If you look, guys, between B and C, we have straight line, flat line, parallel to the x-axis. So this means that the speed does not change. The speed is constant. So if you look to the choices, we have here moving backwards at constant speed, moving forwards at constant speed. Actually, we'll choose what? We'll choose moving forward at constant speed, because the bus moves from B to C, it will be forward. So we will write here moving forwards at constant speed. Okay, between C and D, let's return back to the graph. Between C and D, you have straight line, and here we have speed time graph, so we have constant acceleration. So it will be constant acceleration. We have constant acceleration. That's it. B. The average speed of the bus between A and D is 23 km per hour. So this is the speed. This is the speed here. So we can write in the given, this is the speed. Right. Calculate the distance between A and D. Let's return back between A and D. Actually, we want to get what? The time here. Between A and D, we have 2 minutes. 0 and 2. So the time between A and D, it will be 2 minutes. So he asked me about the distance. So distance equal speed multiplied by time. So it will be equal 23, which is the speed, 23 multiplied by time. And we said that we have 2 minutes. We have to change it into hour according to the given. So it will be 2 divided by 60 to change it into hour. It will be 0.77 kilometer km according to the given. Next. C. The bus stops at D. The bus stops at D. If we return back, stops at D, as you see. And for 1 minute, and then travels at a constant acceleration for 30 seconds. On figure 1.1, sketch a possible graph for the additional motion. Label X when the bus starts to accelerate, and label Y for 30 seconds later. Actually, if we return back to the graph, as you see, he said the bus stops at D for 1 minute. So the bus from here, from this point D, it will move in a straight line 1 minute. So from 2 to 3 minutes. from 2 to 3 minutes. So the line will be like this, just 1 minute. And after that he said 1 minute, and then travels at a constant acceleration for 30 seconds. Constant acceleration means a straight line from here for 30 seconds. And 30 seconds it will be in this point, because here 3 and 4 minutes between them, just 0.5 minutes. So it will move in this direction just till this point for 30 seconds. If we start to draw line to the x-axis, it will reach 30 seconds, this point, which is 3.5 minutes. 3.5 minutes. So here, this is the second stage. He asked me to draw or label x when the bus starts to accelerate. So this point will be x, because the bus starts to accelerate. So this is x. And label y for 30 seconds later. 30 seconds, so this point will be y, this point y, and this point is x for 30 seconds in this point, from 3 to 3.5 in 30 seconds. That's it. Thanks a lot.